And we'll get started with the DFB pump sizing. All right, so our Dulco Flex product line. We're gonna, like Jim said, we're gonna focus on the DFB series, roller pump series. If you're familiar with the Paraflow line, yeah, our pump is similar. I don't want to ever say that it's the same, because there are some differences, some small differences in between the two pumps, but overall we can relate to the Paraflow pump more closely than any other hose pump because of the design. Their pumps are the Paraflow AMP and the Kentuff series. We carry the Dulco Flex standard pump, which performs the same job as the AMP, and the Dulco Flex with Halar coating, which performs the same as the Kentuff series. These pumps are mainly used in industrial and municipal applications. It's a heavy-duty pump. It's not your typical lab pump. It's very rugged. Flow ranges are from 1.3 gallons an hour all the way to 390 gallons an hour. And this takes up all the sizings that we have. We have from 10 millimeter all the way up to 22 millimeter pumps in the B series, which we'll talk about here in a little bit. Max pressure 115 for the hose, and we'll talk about the hoses a little more later on as far as what kind of material they're made out of and which ones we stock. And we also carry a Norprene tube for applications of 30 psi or less. So that's another way of going about it. That tube can be used in all the pumps from the 10 to the 22 at different sizes, of course. It's a roller technology, which we'll talk about here in the next slide a little more about what the advantages of roller technology over shoe technology is. As you know, our competitors, which we'll talk about here in the next couple of bullets, the majority of them use shoe-style pumps, Watson-Marlow, Verter, and they don't provide a roller-style pump unless we're talking about a casing pump, which is totally, it does the same thing, but a little different. Some of our major competitors, like we said, Watson-Marlow, they are the kings of the hose pump business in the U.S. and worldwide. Verter Flex, they have a good footprint here in the United States and very large also out in the international. Obviously Paraflow, and one of the things that we've been telling our distribution channel is to obviously focus on a lot of the Paraflow applications that are out in the field, because we can start getting in the door by just offering replacement parts, because our pumps can use the same parts as the Paraflow pumps. So if you're able to get into a location where they're using Paraflow pumps and we can provide the replacement parts, then we can move on from there to possibly providing new pumps for that. And Walls and Tiernan. All right, roller and shoe technology. Because there's minimal friction between the hose and the rollers, there's lower starting torque and operating torque. This is very important, because we can actually put our pumps that use the roller technology to use a smaller motor. Does not require the torque. The starting torque is not as high as a shoe pump, and the reason for that is because we have bearings in the rollers. And so it's a very smooth transition when you start the pump up. You don't have to worry about breaking of the shoe from the hose. With lower torque requirements, there are typical lower power requirements, like I just mentioned, when using rollers. So that's a very high advantage of using roller technology. Utilizing the lower torque requirements allows for much wider turn down range and the ability to maintain a much lower speeds while holding systems pressures, even as low as 1 hertz. One of the major detractors from the shoe pumps is we are limited to a low RPM of, they can go no lower than 3 to 5 RPM, and that's due to the fact of the shoe and not having the, not being able to break away from the hose. So basically the shoe will be locked on the, at those low speeds, which is obviously not good. With the roller, you won't have that issue because of the bearings that allow for free range on the hose. The design is suitable for operating pressures up to 116 psi with reinforced hoses and 30 psi with tubing, which we'll talk here in a little bit more, like I said, about what kind of materials of hoses we stock here at PFC. All right, so how to pick the correct pump. Here are the main factors. And these are very important factors that you all need to look at when you're deciding on what kind of pump you're looking at and what for what kind of application. So first of all, the material being pumped, we need to find out if it's something that's going to be compatible with aluminum, or if we have to actually use our halide coated pump because of the harshness of material. For example, for sodium hypochlorite, we would want to use our halide coated pumps instead of the aluminum regular standard pump. You want to know what your flows are, gallons per hour or gallons per minute. One of the keys things to hose pump technology is the slower you run the pumps, the longer the life of the hose will be. You have to take in consideration that hose life is based on the amount of compressions that the hose receives. So the quicker you run it, just like a car tire, the quicker and more harsh the environment is, the quicker that hose is going to need to be replaced. System discharge pressure, not pump max pressure. So what we mean by that is this: whenever you're looking at a spec, a lot of times that spec is written around a pump pressure and not the system pressure. So make sure that you guys look at and ask the customer what your actual system pressure is going to be, so when it comes time to pick out the correct pump, we're not over using too many shims to over pressurize the pump. The more pressure on the hose, obviously, the less of hose life you'll have. Temperatures, 175 max, 175F max. And the reason why is because you're dealing with rubber materials. Obviously, the higher the temperature, that rubber material is going to start to soften up. So you're going to lose the ability of the hose to reinflate correctly or deteriorate completely. So make sure you stick with that you look at those temperatures and stay below 175. My recommendation, yes, 175 is the max, but if you can stick with 165, 160, you should be fine. Viscosity. Why is viscosity so important? Here's why. You've got to think of the old milkshake in the straw adage. It's very hard to suck the milkshake through the straw because of the thickness. So you got to remember, viscosity is very important. So if we're pumping a material that's very viscous, you may have to upsize the pump, meaning you may have to get a larger pump to do the same work that a smaller pump would do at the same flows or RPMs. So you need to make sure that you run the pump as slow as possible with high viscosities, so we can get the product into the hose without it, because if you're not able to get the product into the hose, you're going to get hose cavitation, and thus you're not going to get any product through your system. Another thing to consider is intermittent or continuous duty. With this, one of the things that I recommend looking at is continuous duty for hose pumps. We should try to limit that to, or we should call continuous duty an 8-hour shift. One shift should be considered continuous, because like I said, that is based on your hose life. So if you've got a customer that says, I'm running the pump 8 hours a day, you should consider that as a continuous duty operation. So we're still on the how to picking the correct pump. At max continuous pressures, the following hoses at 115 psi are available as standard options: natural rubber, EPDM, and Buna N. Those three are always stocked here at PFC. Hypalon is a special order hose. We can provide Hypalon, but it's on case by case, and pricing may be affected on that because it's not a normal offering that we provide. But we can, if need be, we can provide Hypalon. All these hoses are, as stated before, rated up to 115 psi. Norprene only used for 30 psi or below applications. So keep that in mind. Something else to keep in mind here is speeds versus pressure. Just go back to basic physics, and when we talk about velocity and pressure, the basics of that. At 86 RPM, which is the max RPM that we're going to offer on our DFBs, 30 psi should be the max that you should be running for an 86 RPM application on a hose, and obviously the tube is 30 psi as well. At 68 RPM, 60 psi is recommended. Tube still at 30 psi. 49 RPM or below, you can run all the way up to 116 psi. These are recommendations, and the reason why we recommend these is to have, once again, extended hose life, because that is the main and that is the only part of the pump that ever sees the material being pumped. So the longer we can keep the hose going, the happier our customer is going to be. Gearbox selections for the DFB pumps. The 10s through 19s, so DFB 10, DFB 13, 16, and 19 use the same size gearboxes. These are provided to us by Nord or Emerson. So those are stocked here as much as we can, or they have to be specially ordered depending on what the certain gear ratio that you're requiring. DFB 22s, they have a separate gearbox selections from the 10s through 19s, but they also use the Nord or Emerson gearboxes. The DFB 10 through 19 gearboxes range from 5 RPM to 86 RPM. Remember, we do not want to go, there's gearboxes that are provided that can go higher than 86 RPM, but we have decided here at ProMinent that 86 RPM will be the max that we will offer on that. On the DFB 22s, gearbox range from 9 RPM to 87 RPM. Same thing. We will not go over 87 RPM on applications. Very important point here, pumps will not be sold without gearboxes, but can be sold without motors. Without the gearbox, rotors cannot be mounted to the pump head. It's very important to be able to mount the rotor to the gearbox. That's the only way to do it on the DFBs, and that is the only way that we can make sure that the hoses are being sealed when installed. So we will not provide pumps without gearbox. It'll be pump, gearbox, and motor, but you can opt out of the motor if need be. Talking about motors. For the DFB pumps, we're providing 0.5 horsepower motors to 1 horsepower motors, and can be offered as follows. We got single phase fixed speed motors, standard 3-phase 1001 motors, then chem duty washdown motors, depending on what your spec calls. We can provide either or. We can also provide explosion-proof single-phase motors and variable speed 3-phase explosion-proof motors. Keep in mind with the explosion-proof motors, if you are requiring a VFD, it will not be mounted on the pump. It'll come separate. So you will have to mount that VFD separate away from the pump because the VFDs are not explosion-proof rated. Pumps can be provided without motors, like we stated before. It will include the pump head with hose, rollers, gearbox, and the gearbox is a NEMA 56C phase input. We can also, Jim asked me to mention this, if need be, we can provide a gear motor. It's not part of our normal selection, but it can be provided if need be. So that's another factor. It's a little, the cost is cost effective. Sometimes what we found out is customers like the fact that they can swap out individually motor or gearbox if they need to without having to swap out a whole unit. And that's the reason why we went gearbox motor. But we can provide a gear motor if need be. Connections for the DFB pumps. Our standard connections are stainless steel MPT, PVDF, PVC, and tri-clamp in stainless steel. Sizing on these connections range from 3/8 inch to 1 inch connections. MPT for those, I'm sure everybody here knows MPTs are threaded. Leak detection. Pumps can be provided with or without leak detection. That is up to you and what your spec calls for or what your customer requires. Leak detectors are mounted to the front cover of the pump and must be wired to a VFD or a relay kit for power operation. VFD controls. Pumps can be provided with or without VFDs and are available as follows. Basic VFDs are 115 or 460. Those are mainly used in our industrial applications. And the advanced VFD, 115 or 460, are normally used in our municipal applications. Doesn't mean that the industrial can only have the basic. If you wish to have the advanced VFD for an industrial application, you may do so. Corrosion resistance options. All DFB pumps have the option to be provided as a standard or chemical version pumps. Like we talked about at the beginning of the presentation, we could provide our standard pump is just an aluminum, it's the aluminum casing with the